paper 4 summarized البيبر 4 والمين نولج اللي المفروض اي طالب لازم يكون عارفها قبل ما يدخل امتحان بيبر 4. ايه سمرايز الحاجات اللي لازم اكون عارفها بالنسبه لبيبر 4؟ اول knowledge a difference between Haber pros and contact pros. Haber pros و contact pros ايه النولج اللي انت عايزك تكون عارفها؟ اول حاجه as a comparison بين الاثنين الايكويشنز والكونديشنز. فبالنسبه عندنا للهابر والكونتاكت ايه الايكويشن N2 plus 3H2 gives 2NH3. Contact 2SO2 plus O2 gives 2SO3. Both reactions are reversible, two directions, and both reactions are exothermic. From where you obtain nitrogen, fractional distillation of liquid air. From where we obtain hydrogen, cracking of alkane or electrolysis of water. From where you obtain sulfur dioxide, burning fossil fuels containing sulfur. Conditions: temperature 450 for both, pressure 200 atmospheric pressure and 2 atmospheric pressure, catalyst iron and vanadium pentoxide. Then explain why we are using low temperature, high pressure, adding catalyst, and then why we didn't use temperature less than 450, like for example 300 degrees Celsius. Explain why for each of the following. At the beginning, low temperature because the reaction is exothermic. So by decreasing temperature, reaction moves forward and more yield is produced. So explain why we are using low temperature, because the reaction is exothermic. So by decreasing temperature, reaction moves forward and more yield is produced. In case of high pressure, why are we using high pressure? Pressure depends on number of moles. By increasing pressure, the reaction moves to the less number of moles. We have 4 moles and 2 moles, 3 moles and 2 moles. So the number of moles of reactants is greater than product. So by increasing pressure, the reaction moves to the less number of moles. So it moves forward and more yield is produced. So high pressure, because the number of moles, because by increasing pressure, the reaction moves to the less number of moles. So it moves forward and more yield is produced. So it moves forward and more yield is produced. Adding catalyst to speed up the reaction. Why we didn't use lower temperature like 300? By decreasing temperature more, the reaction will be too slow and costs more. The reaction will be too slow and costs more. This is number one. So number one, difference between Haber pros and contact pros. In Haber pros, N2 plus 3H2 gives 2 NH3, contact 2SO2 plus O2 gives 2SO3. From where we obtain nitrogen, hydrogen, and sulfur dioxide, nitrogen fraction distillation of liquid air, hydrogen cracking of alkane or electrolysis of water, sulfur dioxide burning fossil fuels, and the condition for the reactions, temperature 450 for both, pressure 202, catalyst iron and vanadium pentoxide. Why we are using low temperature, high pressure adding catalysts and temperature not to be used lower than 450? Because in case of lower temperature, because the reaction is exothermic, so by decreasing temperature, reaction moves forward and more yield is produced. High pressure, because by increasing pressure, the reaction moves to the less number of moles, so it moves forward and more yield is produced. Adding catalyst to speed up the reaction. Temperature not to be lower than 450 because the reaction will be too slow and costs more. Number two, factors affecting rate and factors affecting equilibrium. For factors affecting rate and factors affecting equilibrium, and the difference between rate and equilibrium. What is the difference between rate and equilibrium? Rate, it means that a change per time for the rate, and rate affects speed, not amount. To be faster or slower only, but the same final amount. Equilibrium affects amount, not speed. So again, the difference between rate and equilibrium. Rate affects speed, not amount. Equilibrium affects amount, not speed. So in case of rate to be faster or slower, same final volume or same final amount. Factors affecting rate, temperature, pressure, concentration, catalyst, light, and surface area. All of these factors affecting directly by increasing any factor, the rate of reaction increased. So by increasing temperature, pressure, concentration, catalyst, light, or increasing surface area, the rate of reaction will be faster. For example, if you have two reactions and then we have faster rate and slower rate, you will find that both reactions have same final volume or same final amount, but the difference in timing, faster rate, it means shorter time, but the amount must be the same. So rate affects speed, not amount, and factors affecting rate, temperature, pressure, concentration, catalyst, light, and surface area. In case of temperature, by increasing temperature, particles gain energy, so more collisions and faster rate. Pressure and concentration, particles gets closer, more collision and faster rate. Catalyst, lowering activation energy. Light, in food synthesis process and photographic films. In food synthesis process, plant absorb carbon dioxide, water, chlorophyll, and sunlight to produce glucose and oxygen. While in case of photographic films, when light falls on silver bromide, silver accepts its electron from bromine and its color appears. By increasing the intensity of light, it becomes more darker. Surface area, by increasing surface area or decreasing particle size, the rate of reaction increase. In case of equilibrium, equilibrium it depends on temperature, pressure and concentration only. So catalysts, light, and surface area doesn't affect equilibrium. Only temperature, pressure, and concentration affecting equilibrium. So at the beginning, for the rate and temperature, by increasing temperature, particles gain energy. Particles moves faster. More collisions. Faster rate. In case of pressure and concentration, particles gets closer. So more collision and faster rate. Catalyst, lowering activation energy. What's meant by activation energy? Activation energy is the minimum amount of energy to start the reaction. And for surface area, by increasing surface area, it means that decreasing particle size. It have more collision and faster rate of reaction. And for the light, in case of photosynthesis process and photographic films. And in case of photosynthesis process, chlorophyll is used as a catalyst, absorbing carbon dioxide and water in the presence of sunlight to produce glucose and oxygen. So it makes its own food. And photosynthesis is endothermic process. Photographic films, when light falls on silver bromide, silver accepts its electron from bromine and its color appears. By increasing the intensity of color, it becomes more darker. After that, explain the rate of reaction. Rates at point A, point B, and then at point C. Number one, at A, rate is maximum. Why? Concentration of reactants 100%. So at T equals 0, rate maximum, concentration of reactant 100%. At B, rate is slowing down. Explain why. Concentration of reactants decreases gradually. At point C, rate equals 0. Explain why. Reaction is finished. All reactants are used up. Concentration of reactants equals 0. And what's the difference between faster rate and the slower rate? Faster rate, so more steeper if it's directly proportional, and less steeper if it's inversely proportional. Like if you have faster rate, and in case of inversely, it is a faster rate. But in both, we must have same final amount. For equilibrium, factors affecting equilibrium. What's meant by equilibrium? Rate of forward reaction equal rate of backward reaction. And concentration of reactants and products is still constant, not equal, is still constant or not changed. So again, what's meant by equilibrium? Rate of forward reaction equal rate of backward reaction, and the concentration of reactant product doesn't change. For concentration, pressure, and temperature. Concentration, by increasing concentration, the reaction moves from high concentration to low concentration. Like, for example, if you have concentration can be used for liquids, while pressure can be used for gases. So, for example, if you have HCl plus NaOH gives NaCl plus H2O, or if we have inner reactions and then like CH3 COOH plus C2H5OH gives CH3 COO C2H5 plus H2O. By increasing the concentration of reactants, the reaction moves forward and more yields produced. So again, at the beginning, concentration. By increasing concentration of reactants, reaction moves to the product. If we increase the product, moves to the reactants. And then if we have any color at any sites, if it moves forward, so it will take the second color, or if we have colorless and brown, for example, and moving from colorless to brown, we can say it becomes darker. And if it moves from dark color to the paler, we can say it becomes paler. So concentration, by increasing concentration, the reaction moves from high concentration to low concentration. In case of pressure, it depends on number of moles. By increasing pressure, the reaction moves from more number of moles to the less number of moles. So we have three cases. If the number of moles of reactants is greater than products, so by increasing pressure, reaction moves forward and the more yield is produced. If we have the number of moles in product is greater than reactants, so we must decrease the pressure to make the reaction moves forward. In case of number of moles of reactant equal number of moles in products, so pressure doesn't affect. Why? Equilibrium state, equal number of moles in both sides. Like, for example, if you have N2 plus 3H2 gives 2NH3. 2SO3 gives 2SO2 plus O2. H2 plus I2 gives 2HI. In the first one, there is 4 moles and 2 moles. By increasing pressure, the reaction moves to the less number of moles. In the second one, number of moles and products is greater than reactants, so we must decrease pressure to make the reaction moves forward and more heat is produced. In third one, number of moles are equal in both sides, so pressure doesn't affect. So if we have the number of moles and reactants greater than product, we must increase pressure to make the reaction moves forward. In case of number of moles and products is greater than reactant, we must decrease. If they are equal, pressure doesn't affect. What is the advantage and disadvantage for the first one to increase pressure? Faster rate and more yield. What is the advantage and disadvantage? Second one, to decrease pressure, we have advantage, more yield, and disadvantage, slow rate. If we increased, so we have faster rate but less yield. In case of temperature, it depends on the type of reaction to be endothermic or exothermic. In case of endothermic reaction, by increasing temperature, reaction moves forward, while in case of exothermic reaction, we must decrease to make the reaction moves forward. So we have two special cases. In case of pressure, if the number of moles in product is greater than reactants or exothermic reaction, we must decrease pressure or we must decrease temperature to obtain more yield. But in this case, in case of pressure greater than reactance or exothermic reaction, we must add a catalyst. Why to add a catalyst? To speed up the reaction. So like in case of Haber pros and the contact pros, we will find that when we are using low temperature to obtain more yield, but we have a slow rate. So we are adding catalyst to speed up the reaction. This is number one. After that, for extraction of metals, in extraction of metals, we have extraction of iron and then making steel, extraction of zinc, and extraction of aluminium. Extraction of iron from iron rich sites, hematite, this is the ore. Extraction of zinc from zinc blende or zinc sulfide. Extraction of aluminium from aluminium oxide that is called bauxite. So the ore that we have, iron oxide, is called hematite, zinc blende or zinc sulfide, aluminium oxide or bauxite. For the first one, extraction of iron. The extraction of iron, we must know that. In blast furnace, we must add iron oxide, hematite is a source of iron, coke or carbon, source of energy, limestone or calcium carbonate to remove impurities. At the beginning, carbon reacts with oxygen to form carbon dioxide. Then carbon dioxide reacts with more carbon to form carbon monoxide. Then iron oxide reacting with carbon monoxide to form iron and carbon dioxide. After that, limestone is heated to form lime and carbon dioxide. Calcium oxide, metal oxide, which is basic, react with non-metal oxide, sulfur dioxide, to form calcium silicate, is a slag. For the first equation is the exothermic equation. So mention the exothermic equation, carbon reacts with oxygen to form carbon dioxide. So what is the importance of carbon as a source of energy? And they produce carbon monoxide that reduce the iron oxide into iron. In second and third equations is the redox reaction, oxidation and reduction reactions. And then limestone is heated to form lime and carbon dioxide, the thermal decomposition. After that, calcium oxide, metal oxide, which is basic oxide, react with non-metal oxide, which is acidic oxide, to form slag. This neutralization reaction to forming slag. So carbon reacts with oxygen to form carbon dioxide reacts with carbon to form carbon monoxide. Carbon monoxide reduces the iron oxide into iron. Then limestone is heated to form lime and carbon dioxide. Calcium oxide, which is basic oxide, reacts with acidic oxide to form slag. This is at the beginning. After that, you will find that molten iron is formed and slag is formed. But in case of slag, you will find the slag floating at the surface of molten iron. Explain why. To prevent oxidation of iron. So molten iron is formed and then floating at its surface there is a slag to prevent oxidation of iron. This is extraction of iron. After that, making steel. What is the difference between iron and steel? You will find that steel consists of iron and carbon. So in oxygen converter, we have molten iron. And then by passing oxygen current on molten iron by passing oxygen current on molten iron. What will happen? Impurities oxidized. So impurities oxidized. Carbon reacts with oxygen to form carbon dioxide, gas evolves. Sulfur reacts with oxygen to form sulfur dioxide, gas evolves. And silicon reacts with oxygen to form silicon dioxide, which is sand. Then limestone is heated again to form lime and carbon dioxide. Calcium oxide then reacts with silicon oxide to forming calcium carbonate slag. Then slag is removed and carbon is added. So again, in making steel, the difference between iron and steel, you'll find that steel is harder and resisting corrosion. You'll find iron with carbon is a steel. By passing oxygen current in molten iron, impurities oxidized. Carbon reacts with oxygen to form carbon dioxide. Sulfur reacts with oxygen to form sulfur dioxide. Silicon reacts with oxygen to forming silicon dioxide. And then calcium carbonate then heated to form calcium oxide and carbon dioxide. Calcium oxide reacts with silicon dioxide to forming calcium silicate, which is slag. Slag is removed and the carbon is added. Then extraction of zinc. For extraction of zinc, at the beginning, we have roasting. What is meant by roasting? Heating strongly in air. So you'll find that zinc sulfide reacting with oxygen to form zinc oxide plus sulfur dioxide. After that, reduction, it reduced by carbon. So zinc oxide reacting with carbon to form zinc and carbon monoxide. So we can reduce zinc oxide by carbon to form zinc and carbon monoxide, or we can reduce zinc oxide by carbon monoxide to form zinc and carbon dioxide. After that, distillation. So we have three processes. Roasting, heating strongly in air to form zinc oxide, then reduced by carbon. After that, distillation by evaporation, then condensation to be collected. So it evaporated at the top of the furnace and then condensed to be collected. After that, extraction of aluminium. Extraction of aluminium, we have aluminium oxide that is called bauxite, dissolved in molten chloride. Why? To decrease the melting point of the mixture and increase conductivity. After that, you will find that aluminium oxide, molten, positive and negative. Positive moves to the negative, negative moves to the positive. Positive is the anode, oxidation takes place. Negative is the cathode, reduction takes place. And then oxygen is formed at the anode and aluminium is formed as the cathode. After that, to write the ionic half equations, at anode, you will find that we have 2O negative 2 forming O2 plus 4 electrons. And then the container made of carbon or coke or graphite, then carbon reacts with oxygen to form carbon dioxide. Gas evolves. At cathode, aluminium reduced to form aluminium ion reduced to form aluminium atom. These for extraction of metals. After that, making salts. For making salts, we have three methods: neutralization or excess method, and titration, and then precipitation. What is the difference between them? Neutralization, we are using base, solid, which is metal, metal oxide, metal hydroxide, metal carbonate, reacting with acid to be aqueous. While in case of titration, alkali, which is soluble aqueous, reacting with acid to be aqueous. And both are used to prepare soluble salt. While precipitation method, two soluble salts reacting together to produce soluble salt and insoluble salt. To obtain the soluble salt, we have crystallization. To obtain the insoluble salt, wash with distilled water, then dry. And it's used to prepare insoluble salt. So again, in making salts, we have three methods: neutralization, titration, and precipitation. Neutralization, it is a reaction between base, which is solid, metal, metal oxide, metal hydroxide, or metal carbonate. Metal, metal oxide or hydroxide, or metal carbonate, and must be solid, reacting with acid to be aqueous. While titration, alkali with an acid, both are aqueous to prepare soluble salt. Precipitation, two soluble salts to prepare soluble salt and insoluble salt. If we need to obtain crystals of soluble salt, we are making crystallization, heat, cool, filter, dry. In case of preparing insoluble salt, wash with distilled water, then dry. Like, for example, the reaction between copper oxide as a solid reacting with HCl as aqueous to forming CuCl2 aqueous plus H2O. NaCl or NaOH aqueous plus HCl aqueous forming NaCl aqueous plus H2O. NaCl aqueous plus AgNO3 aqueous forming NaNO3 aqueous plus AgCl solids. You will find that as the first one, base reacting with an acid, so neutralization process, and forming soluble salts. For the second one, alkali reacting with an acid, aqueous, to forming soluble salts, so titration. For the third one, soluble salt reacting with other soluble salts to prepare soluble salt, double displacement, and insoluble salt. So precipitation methods. How can we prepare each method? You'll find that in case of neutralization, in neutralization process, you will find that if we have a beaker, this is a Bunsen burner, and then we have a beaker that containing acid. And then by using spatula to take metal oxide, metal oxide, metal hydroxide, or metal carbonate to be used in excess. And then we have a spatula or glass rod to steering. So we are transferring by using a spatula and then steering with glass rod. So we'll start to add excess metal oxide and steering with glass rod. And at the beginning, you are heating the acid. Why you are heating the acid? To speed up the reaction, and then adding in excess. What's meant by excess? More than enough. Why you are adding in excess? To make sure that all acid reacted. And then steering with glass rod, not with a spatula, not to react. After that, we are making filtration to remove excess metal oxide. Then taking filtrate and make crystallization. Heat, cool, filter, dry. So the steps, the first step, to add excess metal oxide to the acid. Number two, filter to remove excess metal oxide. Number three, crystallization. In crystallization, heat, cool, filter, dry. Heat the solution till crystallization point. Allow to cool, then filter, and then dry. How can we know that crystallization point had been reached? Mixing with glass rod crystals formed. Allow to cool, then filter, and then dry. Drying between two filter papers to prevent melting of the crystals. This is number one neutralization process. Number two, titration. In titration, we have burette and then conical flask. At the beginning, we must fill in the burette with acid, take known volume of alkali, and then adding 2 or 3 drops of suitable indicator. So number one, fill burette with acid. Number two, known volume of alkali, and then suitable indicator. In case of using indicator, if we are using methyl orange, so the color will change from yellow to orange. If we are using phenolphthalein, the color will change from pink to colorless. So it depends on the indicator that you are using, methyl orange from yellow to orange, phenolphthalein from pink to colorless. So fill the burette with an acid, add known volume of an alkali, then add suitable indicator, methyl orange or phenolphthalein, and we must choose one. Then start titration. Titrate until the color change. So the color change, it depends on the indicator we are using. If we are using methyl orange, until the color change from yellow to orange. If we are using phenolphthalein, until the color change from pink to colorless. Number 5, repeat the experiment without indicator. Why you are using indicator? To indicate the ending point. Why you are repeating without indicator? To obtain pure crystals. After that, crystallization, heat, cool, filter, dry for the filtrate. So fill the burette with acid, take known volume of alkali, then add in suitable indicator, methyl orange or phenolphthalein, then start titration until the color change, repeat the experiment without indicator, and then make crystallization. Number 3, precipitation methods. In precipitation, if we have a mixture of salts, then we are adding water and steering. This is number 1. Number 2, filter the mixture. Number 3, if we need to obtain crystals of residue, so wash with distilled water, then dry. If we need the crystals of filtrate, so we must make crystallization. So again, in precipitation methods, number 1, add the mixture in a beaker. Number 2, add water to dissolve, then stir. Number 3, filter the mixture. Number 4, it depends on what you need. Number 4, if we need the residue, wash the residue with distilled water and then dry. If we need for filtrate crystallization, heat, cool, filter, dry. This for making salts. After that, the difference between atoms, ions, and isotopes. Atom electrically neutral. What is meant by neutral? It means that protons equal electrons, or number of protons, positive charge equal number of negative charge. This is in case of atom. Like Na, like Cl, there is no any charge. Na 1123, Cl 1735. Number of protons equal 11, number of electrons equal 11. Number of protons equal 17, number of electrons equal 17. So atom electrically neutral because the number of positive charge equal number of negative charge, or because the number of protons equal to the number of electrons. While in case of ion, so proton equal to electron. While in case of ion, proton not equal to electrons. So we must have positive ion or negative ion. In case of positive ion, proton is equal to electrons. In case of negative ion, electrons is greater than proton. Because in case of positive ions, it refers to losing electrons, while negative ion gaining electrons. So like, for example, if we have Na positive or Cl negative, protons equal 11, electrons equal 10, protons equal 17, electrons equal 18. So you'll find that proton is greater than electron is greater than proton. So in case of ion, what is meant by ion? A charged atom, or ion after, or atom after losing or gaining electrons. So ion is a charged atom after losing or gaining electrons, and the proton not equal to electrons. After that, in case of isotopes, atoms are the same element, and you must say same element, with same number of protons and different number of neutrons, or same atomic number and different mass number. So we say atoms of the same element with same number of protons, different number of neutrons, or same atomic number and different mass number. And in this case, you'll find that protons is equal to protons, electrons equal to electrons, but neutrons not equal to neutrons. Like, for example, if you have C612, C613, C614, protons 6 for all, electrons 6 for all. Neutrons is the difference, 6, 7, 8. So in isotopes atoms of the same element, all of them are carbon with same number of protons and different number of neutrons, or same atomic number and different mass number. And in isotopes, you must know that they are same element, explain why, and they have similar chemical properties. Explain why. In case of why they are same element, because they have same number of protons. Why they have similar chemical properties? Because they have same number of electrons in the outer shell. So this is the difference between protons, neutrons, and electrons to be in case of same element because they have same number of protons, while why they have similar chemical properties because they have same number of electrons in the outer shell. After that, for type of oxides, we have acidic oxides, basic oxides, amphoteric, and neutral. Acidic oxides, non-metal oxides. And they are reacting with a base like NO2, CO2. Basic oxides, they are metal oxides. And they can react with acidic, like calcium oxide, magnesium oxide. Amphoteric react with both acid and base, like zinc oxide and aluminium oxide. Neutral is the opposite, doesn't react with anyone, like carbon monoxide, nitric oxide, and water. And take care that we have CO2 and NO2 like acidic, but CO, NO, H2O, neutral. So acidic oxide, non-metal oxide that reacts with basic oxide, basic metal oxide that reacts with acidic, amphoteric oxide, oxides that reacts with both acid and base, neutral, doesn't react with anyone. After that, for the table that contain different properties for ionic and covalent, metallic, and how can we know the state to be solid, liquid, or a gas? So what is the difference between solid, liquid, gas, metal, ionic, covalent? How can we know this is a solid, liquid, gas, metal, ionic, covalent, joint covalent? The difference: metal, solid, liquid, gas, metal, ionic, covalent, joint covalent, and then aqueous sodium chloride or impure water. Aqueous sodium chloride or impure water. How can we know the difference? By comparing melting point, boiling point, and conductivity through solid, through liquid, melting and boiling, conductivity through solid, conductivity through liquid, and dissolving in water. Melting, boiling, and then conductivity through solid and liquid. Liquid to be molten or aqueous, and then dissolving in water. In case of solid, liquid, and gas, we can compare by room temperature, 25 degrees Celsius. For the solid, the melting and boiling is higher than 25. In liquid, melting is lower than 25 and boiling is higher than 25. Gas, both are lower than 25. So how can we know this is a solid, liquid, or a gas? Only by comparing by melting and boiling point to the room temperature. For the metal, high melting, high boiling, conducts through solid, conducts through liquid, but doesn't dissolve in a water. In ionic, high melting, high boiling, doesn't conduct through solid, conducts through liquid to be molten or aqueous and dissolve in a water. Covalent, low melting and boiling, doesn't conduct and doesn't dissolve. Joint covalent, high melting and high boiling, doesn't conduct and doesn't dissolve except graphite. Aqueous sodium chloride or pure water, high melting and high boiling, doesn't conduct through solid, conduct through liquid, and dissolve. But the difference between sodium chloride, this ionic or impure water, to be melting point to be decreased and boiling point to be increased. So the difference between solid, liquid, and gas only by the melting and boiling. Metal, high melting and high boiling, conduct through solid, conducts through liquid, but doesn't dissolve. Ionic, high melting, high boiling, doesn't conduct through solid, conducts through liquid, and dissolve. Covalent, low melting, low boiling, doesn't conduct and doesn't dissolve. Joint covalent, high melting and high boiling, and doesn't conduct and doesn't dissolve except graphite. Aqueous sodium chloride, so this ionic, high melting and high boiling, doesn't conduct and doesn't conduct through solid, conduct through liquid and dissolve. And to be as impure water, the melting point will be decreased and the boiling will be increased.